Let's talk a little bit about electron configurations. So in this video, the main objective is going to be to write the electron configuration of a given element. I'm not going to take the time to talk about ions in this video because that would put this well over 10 minutes, but we're just going to stick to the basics and the bare necessities on how to be able to do this effectively. When you first see an electron configuration, it can be a little intimidating because it's basically a collection of numbers and letters. One thing you'll see will be coefficients out in front on the configuration. So in this particular example, we've got a 1, a 2, and then another 2. These are the energy levels in which electrons are occupying in this particular atom. There are 7 different energy levels that are possible, and this atom only has electrons in energy level 1 and in energy level 2. The next thing that's going to jump out at you during when you look at an electron configuration is going to be these letters. So there's an S, another S, and the letter P in this example. These letters represent sublevels. So you've got 7 energy levels possible inside an atom, and within these 7 different energy levels there are smaller areas called sublevels. And in energy level 1 there's just one smaller area known as the S sublevel. In energy level 2, however, there are 2 smaller areas. There's a S sublevel area and there's a P sublevel area. So when we look at this example, it tells us quite a bit about this atom. And the last thing that's really important here are these superscripts or these exponents. These are the number of electrons present in these areas. So let's just take a look here at all the information that's given to us in this configuration. This atom has 2 different energy levels that have electrons in it, the first and second energy level. The S sublevel in the first energy level has 2 electrons hanging out there. In the second energy level, in the S sublevel, there are 2 electrons present there. And in the second energy level, in the P sublevel, there are 4 electrons hanging out there. So this atom has 8 total electrons, which helps me identify it. So this atom would be oxygen, because oxygen is number 8 on the periodic table, and it has 8 electrons when it's a neutral atom. And this configuration displays an element with 8 electrons. Now, let's look at how you write these. It's very important that you write configurations in a very particular order. You always start with the lowest sublevels first, and you keep filling electrons till you reach the highest energy sublevels. So, the important thing to figure out is how do you know which sublevels get written first? In the previous example, why did this 1s come first, then this 2s, and then this 2p? Well, if you're able to study this diagram, it's going to be very, very helpful. This is a periodic table that's been broken down into blocks. So there's a purple area here, and it also encases this little area here. So there's a purple section, there's a yellow section, a green section, and the cyan section here at the bottom. These are called blocks on the periodic table, S, D, P, and F blocks. We can use these blocks to write any configuration we need to. So let's say I wanted to write the electron configuration for cobalt. Cobalt's right here. Well, what I'm going to do is read the periodic table like a book, starting from the top and reading left to right and going down each line. So I start my configuration with 1s2. There are 2 blocks here, or 2 little squares, so that's 1s2. Then I go down the next line, and I have 2 little squares here, so that's 2s2. Then I have 2p6, 3s2, 3p6, 4s2. Now this is where it gets tricky. You'll notice this starts at 3. This D block, as it's called, is in the 4th row, but it actually is 3D. So we have 3D 1, 2, 3, 4, 5, 6, 7. So our configuration ends in 3D7. Now, some important things to know. S sublevels can only have 2 total electrons in them at maximum. P sublevels can hold 6 maximum. D sublevels can hold 10. And if you go all the way down to this F block here, you'll see that F can hold 14. So, backtracking a little bit, let's say this configuration for cobalt out loud. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. And even though 3d could hold 10, I only need 7 because I'll run out of electrons here. So let's look at another example, and this might make a little more sense on the next slide. So let's get rid of these marks here. Okay. So oxygen. Let's locate oxygen on the periodic table. It's right here. If you were looking at a regular periodic table that's not one that's broken into electron configuration blocks, you notice that it has the atomic number 8. So it has 8 electrons. I'm going to start at the top of my periodic table. This is 1s1, this is 1s2. So we write 1s2. 2s1, 2s2. We write 2s2. 1, 2, 3, 4. 2p4. This tells us the order we need to fill these sublevels. So, what can we tell about oxygen? Well, it has 8 total electrons. We can do that by just counting its exponents in its configuration. 2 of its electrons are in energy level 1. 6 of its electrons are in energy level 2. There are 2 electrons in the 1s sublevel. There are 2 electrons in the 2s sublevel. And there are 4 electrons in the 2p sublevel. Let's take a look at calcium. Calcium's a little bit harder just because it's a bigger element. So first step again, locate calcium. It's right here on the periodic table. Calcium has 20 electrons. So we're again going to start at 1s2, 2s2, 2p6, 3s2, 3p6, and we end at 4s2. So it looked like this. So we're basically filling sublevels until we run out of electrons. There's an order you have to write them. You always start with 1s, then you go to 2s, then 2p, 3s, 3p, 4s. And if you can study these blocks on the table, then you'll be in really good shape because you can just read this like a book. You read it left to right, and you write down the configuration as you go, and you stop when you hit whatever your element is. Now obviously if you're taking a test on this, you're not going to have a fancy periodic table that looks like this one on the screen. You're going to have just a generic periodic table. So you'll have to kind of envision these blocks as you work through this when you're using a regular periodic table. Okay, let's look at one more. This is bromine. So this one's much more difficult. Bromine is way down here. It has 35 electrons. We will fill the 1s sublevel first, 1s2. Then we'll fill the 2s sublevel. Then we'll fill the 2p sublevel. We'll fill 3s. We'll fill 3p. We'll fill 4s. We'll fill 3d. This is what usually tricks people. You're in the 4th row, but you go 4s2 and then you hit 3d. So that's something you'll definitely want to pay close attention to. And then you get to 4p5. 1, 2, 3, 4, 5 till you hit bromine. And if you add up all of these exponents, you'll notice that they will add up to 35, which is good because that's the total number of electrons that bromine has. So what you really need to do is get really good at studying these blocks and understanding how the order works. Just make sure you realize that S holds 2, P holds 6, D holds 10, and F holds 14. And make sure you know the order. So hopefully this was helpful.